Okay, welcome to today's Soilworks training webinar. My name is Daryl. I'm from MIDAS, and I'll just be walking you through this demonstration today. So, as we had discussed earlier, the topic today will be construction stage analysis of a short excavation. So before I begin, I just want to give a brief overview of what our presentation will cover. So our objectives are to review the basic commands and features of Soilworks. So I understand that many of you are new users, and this will be an excellent opportunity for you to become just acquainted with the basic commands and functions of the software. Learn how to model construction stage analysis. So this is the main topic of the presentation, and after learning this, or after going through this presentation, I hope you all have a sound understanding of how to just model basic construction stage analysis on Soilworks. And last, we'll learn how to simulate the effects of excavation on adjacent structures. So the main sort of objective of this analysis is to analyze the effects of excavation on two nearby structures, two pipes, and I'll get more into that as we go into the demonstration itself. Okay, so what is the purpose of construction stage analysis? The purpose is to analyze the interaction between ground structures, between the ground and structures with each sequence of construction. So here I just have sort of illustrated a sample project that sort of details an excavation project for a tunnel. And as you can see, with each step, there are different sort of elements in place, as well as different sort of forces acting upon this project site. So for each of these stages, an analysis will need to be conducted in order to sort of analyze the effects of all these changes on the site. And also, during any type of construction stage analysis, typically with deeper foundations, there are often temporary support structures that need to be modeled and analyzed as well. Okay, so now what would be the advantage of using Soilworks for your construction stage analysis? So one of the great advantages is that Soilworks allows you to model all of your construction stages in a single file. So as you can see, I have various stages in a sample construction stage analysis project. But with Soilworks, all of these stages can be modeled in a single file and analyzed in a single file as well. So this is particularly efficient because with other sort of software programs that are out there, you would need several different files to model your various stages. But with Soilworks, everything can be done in one file, which greatly increases efficiency and effectiveness. Okay. And this is something that we had discussed before, but the 7 smart features of Soilworks. So as we sort of said, that Soilworks has various functions and features that are very unique to it. Some of these may seem familiar to you: smart results, modeling, surfacing, etc. So these, all of these features are very unique to the software itself, and with these features, you can sort of model your geotechnical projects more effectively and efficiently than before. And last, our reliable technical support. Here we pride ourselves on being able to provide very fast, responsive training and support to our clients. So in addition to the general training sessions, which you're attending now, we also have free custom training sessions. So if you have a particular project that's coming up, or a past project that you did in the past that you'd like to see modeled on Soilworks, we can actually model it for you as part of our training. And once again, this is all free. This is all just comes with being our client. And then you can contact us anytime during office hours for immediate support. So if you you're working on your project and you get stuck or you need some support, feel free to give me a call. And also you can email support queries to ts@midasuser.com. Okay. So here's just the project that we'll be modeling today. And I sent all of you copies of the tutorial, so this should look familiar if you had a chance to review it. But it's a basic excavation project. We have an H-pile that will be installed here, as well as 2 tiebacks, and then 3 different stages of excavation. And during this analysis, we'll be analyzing the effect of this excavation on these 2 pipes here. And we'll also be modeling this H-pile as an interface element, which means we'll be sort of studying how this H-pile interacts with the ground which it's supporting. Okay. And then some of you might wonder sort of where I got my material properties. So all of these came sort of beforehand in the tutorial. So as you can see, I already have my soil material properties as well as my structural properties listed here. And that's something that you'll need, obviously, before you start your project. You'll need to have all of your material and structural properties before you can start modeling your project onto Soilworks. So here's just the table that I'll be referring to for all of my structural and ground properties. Okay. So now that I've given an introduction of sort of the project itself as well as the concept, I'd like to start doing the demonstration or the actual project application now. So I'll just need a moment here, and I'll open the program for you. Okay, so here's the software. I've just opened it up, and right now I'm in the ground module. And the first thing I need to do is just go over my units. So if I go to the bottom right here, as you can see right now I have my units in kilonewtons and meters, but you can change these anytime you like during the project modeling. So my first item of business will be to import my AutoCAD file. So in order to do that, just click on the Soilworks icon in the top left corner and go to Import, and then select CAD file. So as you can see, with this feature, you can just search through the files of your computer to find your AutoCAD file. And I already have mine sectioned out here, so I select this, double click it. As you can see, within a matter of seconds, my AutoCAD file has been imported into the program. Okay, so and also this would save you a lot of time because, for example, if you already have AutoCAD files saved onto your computer, instead of having to redraw them in the program itself, you can just import them directly. Also, all of the drawing features on AutoCAD or on Soilworks are CAD-based. So if you're familiar with AutoCAD, all of these commands here should seem familiar, and you can use these to make alterations on your existing drawing or just to draw the drawing itself just in the program. So that's just another one of those features that's been sort of implemented to make modeling more efficient for you. Okay. So now that I have my model imported, next I'll have to assign or create my ground material properties. So in order to do that, just click on Model, click on Ground Material Property, and then this menu or this wizard will come up. So as you can see, you can either enter all of your ground material properties one by one, but by clicking these boxes here and typing in your properties. But a more efficient way to take care of this would be to refer to the database. So if you click on this tab here, as you can see, a sort of menu comes up of different soil properties and parameters that have been created beforehand. And if you click on this drop-down menu here, as you can see, it's very extensive. So you have many different soil properties and types to choose from. But for this project, let's go to menu 1.1, and we'll select the alluvial layer, the weathered soil layer, the weathered rock layer, and then the soft rock layer. Now, something that's really great about this this menu here is that it's fully user customizable. In other words, you can just, if these material properties are close to your parameters that are in your actual project but not quite close enough, what you can do is just to type, or you can change the parameters yourself by typing in these boxes here. And if you change them, just click Save, and they'll be saved for future reference. So you can actually save all of your soil and material properties from past projects into this database for future reference. Okay. So once you have your materials selected, just click Assign. And as you can see, they're all listed here now with their corresponding parameters. Okay. So now that I have my material properties created, and before I move on, I just want to show you, as you can see, if I go to the left here into the work menu, if I click on this tab here, it'll show me the material properties that I've created. And right now they're in blue because they're not actually being used in the model itself, but we'll assign those very shortly. And just the work menu or the work window is just a good way to keep track of everything that you create in the program. So anything that you create will be recorded here, and you can just refer to it very intuitively. Okay. So now my next step will be to create my structural properties. So if I click on this tab here, Structural Property, as you can see, this wizard or this menu comes up. So we have 3 different structural properties that we'll need to create. So let's create the first one right now. So the first one will be pipe. So we'll just enter pipe in the name. It'll be a beam type element, but first let me just show you the different elements that are available to you. So as you can see, almost any type of element type that you would need in your geotech project are already here and available for your selection. And then now let's choose the shape. Let's choose a rectangle shape, and let's define the dimensions, the height and the width. So for the height, let's put 0.03 meters. And for the width, let's put 1 meter. Okay. As you can see, the stiffness calculation is automatic. Okay, and now if you go click on the Material Data tab, as you can see, your properties come up, and these are, customizable as well. So say if I want to change the modulus of elasticity, I can just change it very easily, and as well as the Poisson's ratio and the unit weight. So let's change this to 24. Okay, so now that I have everything created, I can just click Add, and now I have a pipe in my structural properties to choose from. Now let's create the final two structural properties. So next we have an H-pile. So let's enter the name accordingly. It will be a beam type element, horizontal spacing. Let's make it 1.8. And now here's the section. We'll just create the shape. Now obviously it's an H shape, but all of these are available to you as well. Okay. And now let's create the section dimensions. So let's put 0.298, B1, which is the width of this sort of flange here, 0.201, TW, 0.009, then TF1, 0.014. Okay. And then once again, if you need to change the material data, you just go to this section here. Let's keep it the same for now. Now that I have my material, my section properties created, I can just click Add, and now I have my H-pile. And last, I need to create my anchors. So for this one, just type anchor, obviously, into the name. And then for the member type, select embedded truss, because it'll be an underground truss or a tieback. And then the section, make it a strand. And then for the area, it'll be a very small area of 0.000395. Okay, so now that's created, I just click Add, and I have my 3 structural properties here. And once again, if you want to, review or work on the work window, if you click on this tab here, as you can see, your structural properties all show here. Now, once again, these are all in blue, which means they currently aren't in use by the program yet. So before we can assign structural and material properties to our drawing, we need to create our smart surfaces. So in order to do that, just click on Geometry, and then click on Smart Surface. As you can see, now all the enclosed areas are colored in, and now they can be assigned, various structural and material properties. So this bottom layer here will be all soft rock. So in order to select them, just use the box menu, or the box selection feature, and then drag and drop soft rock. And then our next layer will be weathered rock, which will be this sort of second layer right here. So let's zoom in a little bit, and it's all selected, and then drag and drop. And then weathered soil, drag and drop, and then finally our alluvial layer. And then we'll drag and drop that as well. So as you can see, the drag and drop feature is very intuitive. It's just a matter of selecting your surfaces and then dragging your appropriate or your corresponding properties to the drawing itself. And if you want to double check just to see, or just to make sure that your properties have been assigned, just select your surface and then right click on it and select Object Information. As you can see, it'll tell you Smart Surface 18, the layer set or the layer number, as well as the property that's been assigned to it, soft rock. Okay, and then here you can keep track of your layers as well, and you can sort of tell which one corresponds to each by turning them on and off. Okay, so now that I have my ground material properties assigned, next I'll need to assign my structural materials. So first, let's assign our H-pile here. So if we click from, if we click, or if you select, or if we select from left to right. As you can see, anything that's enclosed in the box will be selected, whereas if we select from right to left, everything that touches the box will be selected. So this is just important to remember. Like if you want to sort of save time with your selection feature, just select from left to right with this box option here, and everything enclosed will be selected. Okay, so now just drag and drop your H-pile, and as you can see, once it's assigned, it'll even show on on the program window here, it'll sort of reflect the dimensions of the pile itself. And then same with the pipe. Let's select the pipes and drag and drop our pipe features or pipe properties there. And then last, our anchors as well. So if I just select these here and then drag and drop, my anchors have now been assigned. Okay. So now, after all of my material and structural properties have been assigned, now I need to create my meshing, since this is a finite element model. So in order to create my meshing, I would just need to go over to Model and select Smart Mesh. Now, as you can see, there are various other sort of features or other ways that you can create your mesh, but really the most convenient and the most efficient way to create your meshing is to use the Smart Mesh feature. So if you click on Smart Mesh, this window will come up. So let's make very fine and then register each mesh set by domains. So these are just different ways that you can, or different sets of refinement that you can make your meshing. So we'll make a very fine mesh for a very detailed analysis, and we'll just leave these two blanks for now. So we'll press OK. And as you can see, within a matter of seconds, our meshing has been created. Okay, so now that our meshing is created, we'll need to sort of label or to change the labels of our meshing to just make it more easy to recognize our excavation levels. So as you can see, if I click on this tab here under meshing, all of my mesh sets come up, and I can sort of see all of the names they have assigned to them, which are based on their material properties. But let's take a look at this, the alluvial layer over here. So this will be our first excavation level. So we want this to be more sort of easily recognizable as the excavation level. So we'll just change the name. So just right click, then left click, and then change it to excavation level 3. As you can see now, the name's changed. It's more easy to recognize. Now, in order to make this really convenient, I have to go through all of these names and make changes according to the model. But just in the interest of time, I actually have another sort of model set up where I've already sort of assigned all of these names. So just give me a second, and I'll bring that out for everyone. Okay, perfect. So, it's the same project, but now the only difference is, or the main difference is, that all my mesh sets have been renamed, just according to their excavation levels. Okay, so this is particularly important when we're creating our construction stages, to make these sort of more recognizable when we're setting aside, or when we're assigning all of these layers to the various stages. And I'll go into more detail about that later. But now everything's conveniently labeled. Okay. So now my next step would be to create my anchor elements. So I've already assigned these the anchor properties, or actually the anchor structural properties, but because we'll be running an analysis on these tiebacks here, I'll need to create them as elements. So what I'll need to do is I'll just need to go to Model, and then Element, and then go to Create Element. Okay. So let's name the first one, or this first element here on the top section, Level 1. Free stress length. Okay, and then it'll be an embedded truss element, and then now we just need to select the element itself by clicking on the node. So the first node will be this edge over here, and the second node will be right down here by the soil layers. If I click that, as you can see, the node's been created. Now, the element has been created. Now let's create the second level free stress length element, which will just be this bottom section here. Okay, so just change this to 2. Now it's not in blue, which means it's a new sort of element. And make sure this is embedded truss element. So now if I just go from this node to this node over here, it's been created. Now just press enter, and I can create a new one. Okay. Let's create the final 2 elements because we still have to assign these 2 sections here. So let's go name this level 2 anchorage bond length. Okay, and then we'll go from this node to where it ended to this end node over here. Click enter, and it's created. And then level 1 anchorage bond length. And once again, we'll just pick up where we left off here. Click enter, and now our elements have been created. Okay. And if we go to the meshing here, or the mesh sets, as you can see, we have our various anchorage bond lengths created. So this is very important because we need to assign these different sort of mesh sets for the analysis portion. Okay. So next we need to create our interface elements. So I said at the beginning of this presentation that this H pile needs to be sort of or assigned as an interface element just to simulate the interaction of the pile against the soil, or the soil that's being excavated. So in order to do that, we just go to Model, and we'd go to Element, and then go to Interface Element, this tab over here. If you click on it, this menu will come up. So we need to create this from a truss/beam element. So just remember, in our structural modeling, we labeled this a beam element. So in order to select it, just need to select this method here. So truss beam element. So now we can select it. And now we just need to select the H pile itself. So as you can see, actually, let's just go one by one here. We'll just go up to the H pile here and just go by each section. This is a little. This way takes a little longer, but it's I think a lot more accurate. Just to select piece by piece here. Okay, so now I have all 16 elements selected, and now just addition of mesh sets for interface elements. That's key. So it'll make sure to add the mesh set onto the work menu here, and then make sure to specify this as an interface. So we'll just name it interface, just so that we can refer to it easily on the menu. And now that we're ready, we can just click OK. Okay. So as you can see, these red dots here means these are interface nodes, which means the program is taking into account the soil interaction, or not the soil interaction, but the interaction of the soil against this H pile. And if we go to the left here, you know, we have our left and our right links, just to help us with the modeling, or to sort of set aside the modeling of this interface element. Okay. So now, when we run our analysis, you know, this H pile will be set aside, or will be analyzed as an interface element, which is very key to sort of simulating a realistic excavation. Okay, so next let's define our loading conditions. So what we're going to have is some loading over here on this section, as well as some pre-stressed loading on our tiebacks. So in order to model our loading, just go to Loads/Boundaries, and then first let's model the pressure load over here. So as you can see, we have different types of loads that we could model. But the more simple, or the more general loads, are over here. So let's go to pressure load. And then we're going to name this load set overburden load. Make sure to select element boundary curve, so that way we can select these sections, or these curves over here. And then let's specify the load as 13 kilonewtons per square meter. And now let's select our area. So it'll be this portion over here. Okay, so now it's selected in the normal direction. Press OK. And as you can see, now the loading has been applied. Okay, so next we need to create our pre-stressed loads. So once again, just go to Loads Boundaries, go to Pre-stressed Load, and then let's create our first one. So Level 1 pre-stressed load. Okay, so that's the first one. And then we just need to select this element here. So first, let's make it an element. Okay, truss element type, perfect. So let's select it. So if you go to a certain point along this this member here, if I can just get it here, hold on. There you go. It'll select the entire member. And then axial force, let's make it 220 kilonewtons. And then make sure to select pretension to specify pretension loading. Then click OK. As you can see, it shows up over here. So next, let's create our second pretension loading, or pre-stress load, excuse me. Level 2 pre-stress. And once again, it'll just be the same sort of methodology. And then let's select this this element here. Once again, 220, click OK. and our second pre-stress load has been applied. Okay, so now let's define our construction stages. So in order to do that, just go to Analysis, go to Construction Stage. And as you can see, I don't have any construction stages defined yet, but if I click on this tab here, I can create 5 construction stages, and now they'll all be set. Now it's just a matter of labeling them and then assigning them their corresponding mesh sets and layers. So first construction stage will be initial conditions, or original ground. Okay. Initialize displacement, and then click Modify to change it. Second construction stage will be install structures. Initialize displacement, modify. And then the last 3 will be just the excavation stages 1 through 3. Okay, so now they're all named. So now that I have them all named, I just need to assign them their corresponding mesh sets. So let's go to original ground here, and then go to Define Construction Stage Analysis. So now this menu will come up. So as you can see, all of the available input data is listed to the left here. So this is all the all the elements and mesh sets and loads, etc., that are available to you. Oh, actually, before I move forward, let me just do one thing. So sorry, one thing I forgot to do was to assign my boundary conditions, and that's something that needs to be added in my construction stages as well. So in order to create my boundaries, just go to Loads Boundaries, go to Smart Support, and then you can change the name to anything you like, but for now, boundary set will do. And just click OK. And as you can see, all of your boundaries, or all of your boundary sets are created. Okay, so now that I have that done, let's go back to construction stage here. Let's go to Define Construction Stage. So as you can see, I need to have that boundary set available to me in my input data in order for this analysis to go through correctly. Okay. So now first will be original ground. So obviously, all the sets that will be included will just be everything except for the loading as well as the structures. So all of these can just be brought over. Okay. And a faster way to do it would just be to hold Control and just go down and just select everything that you want to include. Okay, so all of that can just go there, as well as inner pipe. And then boundary conditions, obviously, and then self-weight. Okay, so now that's all included. And this is all activated at the current stage. So this is before any construction or excavation. So now we just click Apply, and now the construction stage has been modified. So now if we go to this drop-down menu here, we go to Install Structures. So now all of these previous, or all of these mesh sets here have been activated already. So we don't need to reactivate them. But what we will need to activate are all the structures that will be included in the construction. So we'll go to Pipe, all our anchors, etc. And then all of our loading as well. Let's pull it over, overburden load. And then obviously our interface elements too. Okay, so that'll be our second construction stage. Now just click Apply, and that stage has been created. Now next, we just go to our 3 construction stages. So during the first stage, we just need to deactivate our first level of excavation. And I labeled it actually level 3, just because, going down 3, 2, 1. So the first layer, or level 3 excavation, will be this alluvial layer over here. Just go to deactivated, So now the program will recognize that this layer here will be excavated. It won't be present anymore. But everything that we activated previous will still be activated. Okay. So now just click apply, and now we go to our second excavation 2. So now all of these layers, I think it's one, or it's actually 2 layers. These 2 layers will be deactivated. So go to excavation level 2 excavation 1 and level 2 excavation 2. And then we just deactivate those. Click apply, and now the program will recognize that those layers have been deactivated. And finally, our last excavation stage. So anything that says level 1, we just drag and drop. Oh, excuse me. That stays. Level 1. Here we go. Level 1 excavation 2 and level 1. I believe that's all of them. Okay, perfect. Oh, wait a second, this one too. Okay, so now those 3 layers here will be deactivated, meaning our excavation is complete. Now we click apply. Okay, and then one thing I think I forgot to add was just my pre-stressed loading. So let's put that, I believe it's this second section here, it's activated. Or actually, excuse me, it's this section here. So let's put these in there as well. Perfect. Click apply just to make sure it'll be modified. And now all of our construction stages have been defined. So as you can see, creating your construction stages is really just a matter of visualizing, what's present during a certain stage, and then what's deactivated or what's taken away during the preceding or the following stages. So it's really important if you have a lot of mesh sets to label your stages or your mesh sets clearly, so that you have a clear sort of understanding of what's being deactivated. Hence, I went to all that trouble to sort of label, or to change all my labels, just so that when this portion came up, I could very easily identify which mesh sets were being deactivated. Okay, so now let's define our stage models. Or actually, let's define, let's define our analysis cases. So let's go to Analysis Design, Analysis Control, and then Analysis Cases. Then we'll go to Add, and let's name this Shoring Wall Construction Stage Analysis. Okay, and then change it to Construction Stage Analysis. So as you can see, all of this has been grayed out now, which means that the program recognizes that I've already set my construction stages in a previous step. Whereas if it were another analysis method, you would have to sort of set your input data in this section here. But since this is a construction stage analysis, we don't need to worry about this section. Okay. And before we move on, let's go to analysis control data. So I'm not going to change anything in this menu, but I just want to show you, in order to make your analysis more or less detailed, you could just increase the number of steps you do here. So say I want to make me a more detailed analysis with more results, or more detailed results. I could just increase this to 100, increase this to 5, whatever works for your project, and I would get a more detailed analysis. But keep in mind that the more detailed you make your analysis, the longer it takes to run. So since this is a relatively small project, I've kept the number low, and the analysis should only take about a minute or so. Okay, but just keep that in mind. If you want to make a more detailed analysis, this would be how you do it. So once again, it's just the Analysis Control Data tab under the Add or Modify Case section. Okay. So now that I have my my case created, just click OK. As you can see, now I have my analysis case. Another thing that's important to keep in mind is if you want to create multiple analysis cases, you can do that very simply by adding more. But once again, that's a topic for another webinar, which is parametric analysis. But we'll get more into that later. And if you have any questions about this, once again, feel free to contact me. Okay. So now I have my analysis cases created. Now let's go over to our design options real quick. So let's go to, once again, Analysis Design, and then Design and Report Control. And then let's go to go to Design Options, and then this menu will come up. So once again, I'm not going to change anything, but this is just another sort of, these are just more ways to make your design more detailed, according to your needs. Allowable angular displacement. So this is a way that you can tell the program, your allowable settlement or your allowable angular displacement, so that, if it goes beyond this, your program will make sure to alert you. Okay? So once again, I'll just leave it just according to the preset terms, because, I don't really need to make any changes right now. Okay, and now next, let's define our adjacent structures. So I said at the beginning of this presentation that these two pipes here will be sort of one of the key results that we're looking for. We want to see how the excavation will affect these two pipes here. So in order to create adjacent structures, just go to Analysis, Design, and just click on the Adjacent Structure tab. Okay, when you do that, this menu will come up. So first we have to name our first adjacent structure. So let's name it Pipe 1. And let's just select this pipe here, the big pipe. And let's select Level 3 Excavation, just so that the program recognizes that we want to analyze the effect of the pipe, or analyze the effects of the excavation at this particular construction stage. So we select it. And then we'll just select these three, the two stresses and the axial force, just so that we get results for each of these cases here. And we click Add. Okay, so and it shows over here, here's our first adjacent structure. Now let's create another one for Pipe 2, Excavation Level 3. Once again, these are all checked on. And then just select this pipe here and click Add. So now these two pipes, during the analysis portion, will be analyzed, and we'll get these three results, and I'll show you that in the post-processing. Okay, so that's how you define your adjacent structures. And once again, you'll need to use that feature whenever you're assigning adjacent structures like pipes or foundations or tunnels, etc. So once again, just to recap, just go to the Analysis, Design, Adjacent Structure, and just using this window here, you just need to select the construction stage that you want to analyze it during, as well as the structure itself. Perfect. So now that we have our model created, we can go to our analysis. Now in order to create your analysis, just go to Analysis, Design, Analysis, Report, and now just make sure both of these are checked on. So obviously your only analysis case, that'll be analyzed, and then keep this checked on to create a report for your adjacent structures. And then once you're ready, you can just click Perform Analysis. Now the program, it usually takes about under a minute, or only about 2 or 3 minutes actually, to create your analysis or to run the analysis. But just in the interest of time, I already have a completed analysis file open. Okay, so let me pull it over for you. Okay, here you go. So here is what post-processing looks like. And as you can see, this window over here to the left has changed. Instead of the work window, it's now the results window. And I have my results for each of one of my construction stages. So if I click over here to original ground, and if I open one of these, as you can see, it shows what the site looks like before any construction or excavation has taken place. And then if I go to level 1 excavation, as you can see, this portion here has been removed, and it'll go through, I can go through all of my sort of results for each of these stages. And if I go to level 2, as you can see, the excavation gets deeper. And then finally, level 3, or final excavation, all of my excavated soil has been removed. Okay, so one of the things I want to look at is just sort of the displacement at this top node here. So in order to do that, go to Excavation Level 3, go to Vertical Displacement, and as you can see, this will all pop up. And if you go to the legend here on the right, it'll sort of give you just the numerical values for your different results, so that you can understand your numerical results as how they correspond to your contour graph here. But say I want to import my results into a spreadsheet. In order to do that, just go to Results, go to Table, and then just make sure to select your criteria. So the node that's at the top over here is 743. Okay, keep all of these checked on, so that way you can see the displacement of the node during each one of the construction stages. Click OK. As you can see, it's been exported to a spreadsheet, and it has everything sort of neatly listed. Now let's say I want to export this to a graph. in order to do that, I'll just go to this tab over here, and then this window will come up. Okay, so my graph isn't created yet, but let's check on changing the X direction and click Draw. As you can see, it'll show how this node changes, or how the vertical displacement of this node over its different stages. But right now the stages don't show on this bottom axis here, so let's actually turn that on. So just go to this drop-down menu here and click on Step, click on Draw. As you can see, now it'll label the axis according to the construction stages. And once again, it's not limited to, this option isn't limited to just one node or to one sort of type of result. You can use it for any type of result in this work window here. You just need to follow the same sort of methodology in order to create your graphs and your spreadsheets. And you can use this option here to actually export it to an Excel spreadsheet if you would need to do that. Okay. And once again, if you want to go back to your model, just go onto this tab over here. Or excuse me, you go to this tab over here. Okay. So now finally, next we'll go over the results or the effects of the excavation on this H pile here. We'll get our stresses and our strains and our axial forces, as well as our moments. So once again, let's go to the third level of excavation, already there. And then just click on Beam Member Element Force. So as you can see, if we just zoom in here, I have my forces, my axial forces, my shear forces, as well as my moment diagram on this H pile. And if I zoom into these pipes here, it shows the effects of the excavation on it as well. And also, I can sort of see, if I go to level 2 excavation, if I go to beam element stresses, I can get the results for different construction stages as well. So you can go back and forth between construction stages and see over time how this H pile is affected. Okay. So one last thing I want to show you before we wrap up is just what the report looks like. So as I said before, when you run your analysis, you have the option of running the report generation feature. And what the program does is it takes or it extracts your results and it creates just a Word file for you, so that to make it something more presentable, perhaps to your clients or to your supervisors. So you have your Word document here, and here's your table of contents, and all of this has just been exported directly from the program. So you have the main results that you want to extract or that you want to focus on. So you have your stresses, and then you have your analysis outputs and your drawings as well. So this is obviously a much sort of condensed and smaller version of the report. But this is just, the report generation feature is just a good way for you to sort of condense your results into a presentable format. And obviously if you wanted to create a more detailed report, you just need to specify more things to be analyzed or included in the report. And that's something we can talk about at a later time. Okay. So I hope that this webinar was useful to you all. I'm sorry once again for the technical difficulties we had with our audio, and we promise that in the future we'll be able to get started with our webinars a lot more efficiently. But once again, thank you for your time, and I wish you the best of luck with your use in Soilworks. Take care.